In this video, we are going to introduce another method for simple truss analysis, the method of sections. Once again, for any truss member that is either in tension or compression, if we run an imaginary cut through it, the internal force can be imagined to have been exposed, and it can be considered as external. So now we have a way to apply rigid body equilibrium method to analyze the internal reaction. We will learn more about the internal reactions later. Since, if you recall, one 3D rigid body free body diagram enables us to solve for a maximum of 3 unknowns. So if we only need to solve for the forces in no more than 3 truss members in the structure, we can imaginarily cut the structure open and apply rigid body equilibrium analysis. This is known as the method of sections. Let's look at this example. For this structure, we are not asked to solve for all members, just BC, CF, and CG. Therefore, instead of using the method of joints, we use the method of sections because this way there's fewer steps involved. Here's the plan. Since we need to solve for the forces in members BC, CF, and CG, we can run an imaginary cut through these 3 members. And now the internal forces in these 3 members are exposed. Note how there are actions and reactions on the left and right segment. So we can choose either side for the calculation and we will get the same results. Don't forget, we can only solve for 3 unknowns using one rigid body free body diagram. Therefore, either side we choose, we need to determine the support reaction first. Now, the left segment has only one support reaction associated with the roller, while the right segment has 2 support reactions associated with the pin. So for convenience, we should pick the left segment for further analysis. So the first step for this problem, it is necessary to determine the support reaction at point A. To do so, we draw the free body diagram for the entire structure and summarize the resultant moment about point D. And from this single equation, we are able to solve for the force AY. Keep in mind that for some problems, it might not be necessary to determine the support reaction, so you should use your own judgment. Step 2, cut the structure, and we have already decided to choose the left segment for our analysis. Step 3, apply rigid body equilibrium to solve for our unknowns. We start with a free body diagram of the left segment, and since we have already solved for the support reaction at point A, we have only 3 unknowns, FBC, FCF, and FFG, and we can write 3 equilibrium equations. Remember, normally we would write 2 force equations and 1 moment equation. However, note that how force BC and force CF are concurrent, and force CF and force FG are also concurrent. Therefore, it will be convenient to write 2 moment equilibrium equations about point C and point F. See, when the moment is summarized about point F, only FBC shows up and you can solve it easily from this equation. And when moment is summarized about point C, you only have force FG and can easily solve it as well. Lastly, let's write 1 force equilibrium equation along the x direction, and from it we can solve for FCF. Hopefully from this example, you have learned how to apply the method of sections for your simple truss analysis.